Objectives. At the end of the discussion, grade 9 students are expected to do the following with at least 75% level of proficiency. A. Identifies the nature of roots of a given quadratic equation. B. Describes the nature of roots of a quadratic equation through its discriminant. And C. Develops patience in determining the nature of the roots of a quadratic equation. Good morning, class. Before you sit down, please align your chairs and pick up the pieces of paper on the floor. Okay, if so, you may now take your seat. Okay, Miss President, please check the attendance. Okay, that's good. Everyone is present. Now, how are you feeling? Are you all tired? Well, today you should be alive and kicking, for we will be engaged in an interesting lesson. Are you all ready? So, last time we tackled about quadratic formula, right? Now, who can state the quadratic formula? Okay, that's good. So, how to use the quadratic formula? Anyone? Okay, thank you for that. Okay, class, I have here pictures of numbers. Are you familiar with these numbers? Which of these numbers are familiar to you? Can anyone describe these numbers? Very good. Any other? Okay, well said. You already know what are real and not real numbers, right? Now, who can tell me which of these numbers are real? Okay, very good. How about not real numbers? Okay, that's good. How about rational and irrational numbers? Do you know what are rational and irrational numbers? So, which of these numbers are rational numbers? Nice. How about irrational numbers? Now, who can tell me what are the perfect square and these numbers? Good. Now, who can describe perfect square numbers? Thank you. Very good. Okay, job well done, class. Now, I have here a box, and this box has chips inside. The chips are blue, red, and white. Then I will pass this box to you, and you're going to pick a chip. Understood? Okay. Did everyone pick already a card? A chips? Now all who pick red, please stand. Familiarize your group, okay? All who pick blue, please stand. Okay, you may now take your seat. And all who pick white, please stand up. Now, all of you have the group. Red group stay here, blue group stay there, and white group stay at the middle. So, at the count of 5, all groups must be seated together according to their group assigned area and form a circle. Are you all ready? Now, 1, 2, 3, 4, and 5. Is everyone in their proper group now? Now, today you will have a group activity, and this activity is called Fit Me. Now, I have here a puzzle pieces and a puzzle board. The answers were written in this puzzle board, and the problems are in the puzzle pieces. All you need to do is to solve the problems on each puzzle piece to be able to fit in the puzzle board and complete the puzzle. This is for the red group, and this is for the blue group, and this is for the white group. So there's an instruction in the puzzle board to what you will do. You only have 10 minutes to answer the activity. So you may start answering now. Time's up. Let's now check your work. Red group, give your work to the blue group, and blue group, give your work to the white group, and white group, give your work to the red group. So last time we tackled about quadratic formula, right? Now who can say the quadratic formula? Very good. How to use the quadratic formula? Anyone? Thank you. Thank you for that. Now our lesson for this morning is all about discriminant. In our past lesson, we tackled about the quadratic formula, and it is stated as x is equals to negative b plus minus square root of b squared minus 4ac divided by 2a. Now the quadratic formula makes it easy to determine the nature of the roots of a quadratic equation even without solving the equation. So the number b squared minus 4ac, which appears under the radical sign in the quadratic formula, is called the discriminant. So by calculating the discriminant before solving the quadratic equation, we can predict whether the solutions will be rational numbers or imaginary numbers. So the value can be used to describe the nature of the roots of a quadratic equation. It can be 0, positive and perfect square, positive but not perfect square, or negative. Now, if a, b, and c are integers, then the type of solutions of a quadratic equation ax squared plus bx plus c equals to 0 is determined as follows. So we have the discriminant. If the discriminant is equal to 0, the nature of roots is real and equal and has a one number of real roots. So if the discriminant is greater than 0 and it is a perfect square, then it is a rational and an equal nature of roots and has a two number of real roots. And if the discriminant is less than 0 but not a perfect square, the nature of roots is irrational and unequal and has a two number of real roots. And lastly, if the discriminant is less than 0, it has an imaginary roots or no real roots and has none number of real roots. So we will discuss here about the different cases of discriminant to a nature of the roots of a quadratic equation. We know that x sub 1 and x sub 2 are the roots of the general form of the quadratic equation ax squared plus bx plus c equal to 0, where your a is not equal to 0, then we get x sub 1 is equals to negative b plus the square root of b squared minus 4ac divided by 2a, and your x sub 2 is equals to negative b minus square root of b squared minus 4ac divided by 2a. Your a, b, and c are real and rational, then the nature of the roots x sub 1 and x sub 2 of the equation ax squared plus bx plus c equals to 0 depends on the quantity or the expression like the b squared minus 4ac under the radical sign. Thus, the expression b squared minus 4ac is called the discriminant of the quadratic equation ax squared plus bx plus c equals to 0. Now generally, we denote discriminant of the quadratic equation by d. Therefore, discriminant d is equals to b squared minus 4ac. Now depending on the discriminant, we shall discuss the following cases about the nature of roots x sub 1 and x sub 2 of the quadratic equation ax squared plus bx plus c equals to 0 when a, b, and c are real numbers and your a is not equal to 0. So to further understand, let's discuss each case. Now case 1, b squared minus 4ac is equals to 0, meaning to say your discriminant is equals to 0. Now example, find the discriminant value of x squared minus 12x plus 36 equals to 0 and determine the number of real roots. Now solution. Step 1. Identify the values of a, b, and c. So the given equation is x squared minus 12x plus 36 equal to 0. So the equation is in the form of ax squared plus bx plus c equal to 0, where your a is equals to 1, and your b is equals to negative 12, and your c is equals to 36. So in step 2, you need to substitute the values of a, b, and c to the discriminant formula. So that would be d is equals to b squared minus 4ac. So b squared is negative 12, so that is negative 12 squared minus 4 times 1 times 36, and that will give us a discriminant of 0. So step 3. Describe the nature of the roots. So since the discriminant value of the equation is 0, then the equation x squared minus 12x plus 36 equal to 0 has a double root, and the roots are real and are equal. This can be checked by determining the roots of x squared minus 12x plus 36 equals to 0 using any methods of solving quadratic equation. Example 2. Find the nature of the roots of the equation x squared minus 18x plus 81 equals to 0. So the solution is the coefficients of the equation x squared minus 18x plus 81 are rational. So the discriminant of the given equation is this is equals to b squared minus 4ac, and that is negative 18 squared minus 4 times 1 times 81, and that will give us a 0 discriminant. So clearly, the discriminant of the given quadratic equation is 0, and the coefficient of x squared and x are rational. Therefore, the roots of the given quadratic equations are equal. Now, moving on, case number 2 is b squared minus 4ac is greater than 0, and it is a perfect square, meaning to say your discriminant is greater than 0 and it must be a perfect square. So example number 3, find the discriminant value for the equation x squared plus 5x plus 6 equals to 0 and determine the number of real roots. So solution. Step 1. Identify the values of a, b, and c. So upon identifying the a, b, c, we now go to the step 2, which is to substitute the values of a, b, c to the formula of the discriminant, and that will give us a discriminant of 1. So step 3, how do we describe the nature of the roots? So since the discriminant value of the equation is greater than 0 and a perfect square, then there are two real roots of the equation. So x squared plus 5x plus 6 equals to 0, and the roots are rational numbers but not equal to. This can be checked by determining the roots x squared plus 5x plus 6 equals to 0 using any methods of solving quadratic equation. Now example 4. Still in case number 2, find the nature of roots of the quadratic equation 3x squared minus 10x plus 3 equals to 0 without actually solving them. Now how do we solve? So the coefficients of the equation 3x squared minus 10x plus 3 equals to 0 are rational. So the discriminant of the given equation is 64. So clearly, the discriminant of the given quadratic equation is positive and a perfect square. So the perfect square is 8. Now case number 3, we have b squared minus 4ac is greater than 0 and not a perfect square. So when a, b, and c are real numbers and your a is not equal to 0 and discriminant is positive but not a perfect square, then the quadratic equation ax squared plus bx plus c equals to 0 are real, irrational, and unequal. Here's the roots. X of 1 and x of 2 form a pair of irrational conjugates. So how do we give an example? So example number 5. Describe the nature of roots of the quadratic equation 2x squared minus 8x plus 3 equals to 0. So the solution is the coefficients of the equation 3x squared minus 8x plus 3 equals to 0 are rational. So the discriminant of the given equation is since your b is negative 8, so we have negative 8 squared minus 4 times the value of a, which is 2, times the value of c, which is 3, so that will give us a discriminant of 40. Clearly, the discriminant of the given quadratic equation is positive, but not a perfect square, so therefore, the roots of the given quadratic equation are irrational and unequal. So to check, solve for the roots of 2x squared minus 8x plus 3 equals to 0 using the quadratic equation. So we have the x is equal to negative b plus minus square root of b squared minus 4ac divided by 2a. So we have x is equal to negative times negative 8 plus minus square root of negative 8 squared minus 4 times 2 times 3 divided by 2 times 2. So that will end the case number 3. Now moving on, case number 4. B squared minus 4ac is less than 0. So when a, b, and c are real numbers, and your a is not equal to 0 and the discriminant is negative, then the roots x sub 1 and x sub 2 of the quadratic equation ax squared plus bx plus c equal to 0 are unequal and imaginary. Here, the roots of x sub 1 and x sub 2 are a pair of the complex conjugates. So example number 6. Find the discriminant value of 2x squared plus x plus 3 equal to 0 and determine the number of the real roots. Step 1. Identify the values of a, b, and c. Then the given equation is 2x squared plus x plus 3 equals to 0. Now the equation is in the form of ax squared plus bx plus c equals to 0, where your a is equals to equals to 2 and your b is 1 and your c is 3. So step 2, substitute the values of a, b, c to the discriminant formula. So that will give us 1 squared minus 4 times 2 times 3, and that will give us a negative 23 discriminant. So step 3, describe the nature of the root. So since the discriminant value of the equation is less than 0, then the equation 2x squared plus x plus 3 equals 0 has no real roots or imaginary. So to check, solve for the roots of 2x squared plus x plus 3 equals to 0 using the quadratic formula. Now, I guess all of you understood our topic. I hope you don't forget what we discussed. Now, we will have a board work activity. Everyone, please cooperate and participate. This will test how quick you can solve the problem. Are you all ready? So, to have you in a group, please have a number head starting from your left. Now, please organize yourself by group and assign a number for every item to solve on the board, okay? Are all set? Ready? Now, all number 3, pick one card, and when I say go, and that's the only time you are allowed to open your card and answer it. Okay. Okay, you now go to the board and answer it. Does everyone get the correct answer? Okay, next, all number 5, you may go now. Did they get the correct answer? Okay, good. And last to answer, all number 2, it's your turn now. Pick and go on the board. Do they have same answers as yours? Okay, congratulations class. Great job. I see that you are now learning. Hereafter, let's have now your quiz. It will be recorded, so answer it carefully and recheck your solution. Now task 1. Determine the nature of the solutions of each quadratic equation. Letter A, 4x squared minus 1 equal to 0. Letter B, 10x squared minus 3x is equals to negative 4. And letter C, x squared minus 10x plus 25 equals to 0. Task 2. Determine the nature of the solution to each quadratic equation. Now, letter A, 2x squared plus x minus 3 equals to 0. Letter B is 5x squared minus x minus 1 equals to 0. Good job for that, class. I see that you are really eager to learn. Maintain that no matter who's the teacher, and always build your motivation for it as you who gonna repeat at the end. Now, so much for that. I'm going to have our lecture bring the simple present, the assignment, to let yourself practice and so that you won't forget the lesson you learned today. And as usual, we will check that tomorrow. Are we all clear and ready to take the challenge? Okay, that's all for today. Class dismissed.